So again, we're solving linear systems. This time we're going to do another 2x2 linear system, and we're going to get infinitely many solutions this time. I'm secretly telling you before we even start, because I, with experience, can clearly see, and hopefully you will, especially for 2x2, that this row is just a multiple of that row, so there's no new information in that row by listing it in the equation. It's actually a 1x2 system, but we have to find out. So how do we do that? Luckily, Gaussian elimination to REF will systematically give us the answers regardless of what kind of solution we have. So the first thing I do always is get the augmented matrix. Again, what I want from the scenario is, once I have the augmented matrix, I follow Gauss's mantra, and that is get a leading one in the top left corner and then eliminate any non-zero variables below this. So I'm going to do row 2 goes to row 2 minus 2 row 1 to get rid of this variable, and it turns out when I do that I entirely eliminate the row. So that's what this will look like. 1 1 4 0 0 0 2 minus 2. I'm multiplying by minus 2 this time, and I'm distributing it into every member of the row, and then I'm adding it to this row. So 2 minus 2 is 0, 2 minus 2 is 0, and 8 minus 8 is 0. This is now REF. I do the quick check again in my head. I run it through every time, and then you can't forget what the scenario is to check. If I have any zero rows, they go below non-zero rows. I do have one this time, and it's at the bottom. Good. If I have a leading entry, there's zeros below it, which I have. I only have one leading entry. And the last axiom, technically in this scenario, I don't have to check because there's only 2 rows and one of them is zeros, so I don't have to compare whether the leading entries in the lower rows are further to the right. So that's definitely true. It's vacuously true by default. It's not. It doesn't exist. The scenario doesn't exist. So I'm in REF. Once we're in REF, that's when I check what kind of solution I have. So because I have a row of zeros and I have no contradictions above it, I should also check when I'm in REF. I have infinitely many solutions. But it said solve the system, so what I have to do is explicitly give that general solution. So I do have x1 plus x2 equals 4. So what that's really told me is I've eliminated one of the equations, and so I only have one equation and 2 unknowns. So what we do is one of them's free to be any real number we want. So in general, reverse of k to 12, that we make x the independent variable and y the dependent variable, I'm now going to make x2 or y the free independent variable, and we're going to solve for x1 in terms of or depending on x2. So what that gives me is x1 is 4 minus x2, which is 4 minus t. The general solution, therefore, thus, it doesn't hurt to write out the final what they were asking for in a sentence. The general, if it's legible, solution to the linear 2x2 system, x1 plus x2 equals 4 and 2x1 plus 2x2 equals 8, is given by x1 equals 4 minus t, x2 equals t, where t is allowed to be free or can range over the entire real numbers. There's the infinitely many solutions to that 2x2 linear system.